Okay, so now we're coming back in, our last two problems on the trigonometry worksheet. I would consider these to be the challenging problems. I would do, just like you would on any test, notice that what I've done is I've kind of worked through the worksheet and you pick and choose the ones that you know how to do, you skip over the hard ones, and then you come back to those at the end. So it's kind of the same thing. So, when you're working on your worksheet at home and you're doing your homework, you want to do the easy ones that you know how to do, attempt the harder problems, and if you don't figure them out, come ask me questions, or you can check out the solution videos and see how they're actually going to be worked once I post those videos. So this one, let's come in, let's take a look at our solution video here for, let's start with number 12, the last one. I think that's a little easier than the one that came earlier, so I'll do that one. Now this one, what you kind of need to review. This is for those of you that are in plus, probably did this a little bit more than those of you that were in the honors, but we did work with an identity that I didn't put in the review sheet, but we'll go ahead and we'll mention it here, is notice that this is going from a sum to not a sum. And so this is going to use one of your sum and difference identities. And so the cosine will remind you what it is of alpha plus beta, had a formula that we used when we did sum and difference identities. And it's the cosine alpha, cosine beta minus sine alpha, sine beta. So the sum and difference identity is kind of what they're utilizing here. So I kind of threw this in the worksheet. This is going to help you review that identity. Remember that from when you did this last year in pre-calc. So using this identity, don't forget there's a 4 here. I'm going to go ahead and put parentheses. And I go ahead and follow the identity. I need cosine of x, cosine of pi over 3, minus sine of x, sine of pi over 3. So you kind of just apply the identity. Then you have a little bit of trig ratios to do. We have our 4, cosine of x, and then we have cosine of pi over 3, which is 1/2, minus sine of x, and then our sine of pi over 3, which is square root of 3 over 2, and then we can distribute our 4 to cosine x minus square root of 3 sine of x. And so we find the one up here that has, oh, I can't multiply, can I? 4 with a 2 is going to leave me with a 2 there. And see, the good thing about multiple choice is you can kind of catch those mistakes because you see when you're missing something, like if it doesn't match anything, go figure out what you did wrong. So the answer to this one, 2 cosine x minus 2 square root of 3x, is going to be B. All right, so now let's go back to the most challenging one in this packet, number 8. And that's mostly because this is essentially a proof that you're doing. And so it's making you work a little bit more abstractly, and it's got multiple steps to it. So we're going to work our way through this. Now, the first thing that I would look at is you're like, okay, what I want to do is I want to use this figure, and I want to find the tangent of phi. So the first thing is to look at this problem. I'm going to call this y, and maybe let's call this x, just so I kind of have all the sides labeled with some kind of a variable. That initially, if I'm looking at the tangent of phi, then I'm going to need, and let's put an h in here for this height. So the opposite over here, and I'm going to need the adjacent over here. And so this is A, B, and theta, and right now the problem that you have is that tangent of phi, it's just a Greek letter in case you haven't seen it before, is going to be the opposite side over the height. And so this is the tangent as a function of this new y and h that I put in. And so what you first have to recognize is while you do know something about the tangent of the angle, your problem is that you've now got to find y in terms of a, theta, and b. And you're going to have to find this h in terms of a, theta, and b. All right? Let's start with this triangle right here. So I'll go, okay, in this triangle, let's target this h right here. And let's think about what we know. This h, if I'm looking at this angle theta, this h is an adjacent leg. So just like it was an adjacent over in this triangle, it's also adjacent in this triangle. Okay. And then the a is the hypotenuse. So I have a hypotenuse and an adjacent. which means what trig function are we going to use? Cosine. So the cosine of the angle theta is going to be adjacent h over the hypotenuse a. And I can solve this and find out that h is equal to a cosine theta. So up here in the original expression that I wrote, I'm going to take out the h, and I'm going to put in the denominator a cosine of theta. And so right there, I can leave the y in, we're going to have to get rid of it, but right now I have the tangent of phi as a function of a, theta, and y. So the a and the theta are good, so we're like, hey, that's all great, but the y I need to eliminate. Over here in the first step, I needed to eliminate both the y and the h. Now I've eliminated the h, and now I need to eliminate the y. So I'm going to come over here to the next problem. And we go, okay, what do I want to do? Well, I certainly don't want to use a trig function because this does not have theta in this problem. It has phi, and I don't want it in terms of phi. So then I start asking myself, in right triangles, while we did have trig ratios as one choice of getting some formulas that we can use, our second choice, which was actually more from geometry, is to use the Pythagorean theorem also. And so the Pythagorean theorem is probably going to be a better choice here because I don't want to have phi anywhere in the problem, so I don't want to use that and use a trig ratio. I'm going to go with the Pythagorean theorem. So from the Pythagorean theorem, I'll just put it right over here, I know that h squared plus y squared equals b squared. Now I still have a little bit of the same problem we had before, is that here's my h, which I need to get rid of. Here's my y, which is what I'm trying to solve for over here. B is okay. So what I'm going to do is go, oh, wait a minute, I know what h is. H is a cosine theta. So I'm going to substitute in a cosine theta for the h, square it. We can leave the y squared in there because I am going to solve for it. So y squared equals b squared minus a squared cosine squared theta. And y is going to be square root of b squared minus a squared cosine squared theta. And so you'll see, and I did positive because we're a side length in a right triangle, so it's positive. And now if I take this and I plug it in up here, then I have pretty much everything out that I wanted to get out, which is I don't have any y's or h's or x's or anything, phis or anything in that side. And then if you look at your multiple choice options down here, I need a cosine theta in the denominator. So this one would not work. That one does not work. Both of these are good. This one does not work. That one's out. So that gets me, if you just done this part, you kind of got yourself to here. And now I can look at the top part. I need b squared minus a squared. So my choice is E. And so that will finish out our worksheet for our trigonometry. And come see me if you have any questions or you want to go over anything in more detail.